Okay, so now I'm recording already. Okay, now I'm recording. So I'm recording already. Okay, that's good. Recording. Okay, so let's continue. Well, what we talk about. So today we're going to learn about path difference. Yeah, path difference is because all before this we learn about we learn about this constructive or destructive interference. Yeah, constructive and destructive interference. It need two waves. It need two wave. Yeah. So if the wave have, like, let's say, same displacement, yeah, same direction of displacement, then you have constructive interference. If the two wave have opposite direction of displacement, then it become destructive interference. Constructive interference produce bright fringe, destructive interference produce dark fringe. Kan? So dia perlukan dua gelombang, interaction between two or more wave, overlap each other. So two wave, remember two wave. Then we talk about, if you want to have interference, the wave must be coherent. Coherent means they must have be what we say, same wavelength or frequency. If the two wave are not coherent, they cannot have interference, right? We already learned about this. Yeah, must be coherent, same wavelength, and so on. So, for example, like this double slit. Yeah, double slit. You see, you have two slits here. So that means each slit give out their own wave lah. Yeah, got light wave from S1, got light wave from S2. And these two light wave, they travel different path. Like you can see S1 to B. This path is shorter. Yeah, it's shorter if compared to the light wave from S2. S2 travel longer distance. Yeah, someone coming in. Yeah, someone coming in. Yeah. Okay, welcome. Good night, everyone. Okay, so S1, the path of S1 to B is actually shorter if you want to compare with S2 to B. S2 to B is longer distance. See, S1 is shorter, S2 is longer. So that's why we say they have path difference, difference in their distance travel. So I can say the difference is this part lah. You see that? Because S2 travel longer distance compared to S1. So the extra path, this is the extra path lah. If we draw a line 90 degree to the second line, so the extra path is the path difference, delta L. Remember that? So maybe I should draw. See that? This one is long distance. This one short distance, right? I drew this on during the last. Yeah. So you must draw a line 90 degree to the second ray. So this part is the path difference, we call it. Yeah, or we say that it is a delta L. We call it, this extra distance is the delta L. Okay. Yeah, this one. Yeah, if this delta L is multiples of lambda, 1 lambda, 2 lambda, 3 lambda, you produce bright fringe. If the path difference delta L is half lambda, 1.5 and lambda, and 2.5 lambda, it will produce dark fringe. This one I will explain later. Okay. So this path difference is direct equivalence to phase difference lah. Yeah. As I said just now, 1 lambda is corresponding to 2 pi radian. Yeah. If 1 lambda is equivalent to 2 pi radian. If half lambda is like pi radian. 2 pi radian means like 360 degree lah. Pi radian is like 180. So 1 lambda is like 360 degree. Half lambda is like 180 degree. Okay. So you can call it path difference or phase difference. They are actually the same thing. It's just that path difference refer to length. Phase difference refer to angle. That's it. Yeah, refer to angle. So, okay. So this path difference decides whether constructive or destructive interference may occur. So this path difference decide whether in point B on the screen, in point B, either you get bright fringe or you get dark fringe on point B on the screen. Understand? So it's all determined by this path difference delta L. Yeah, like you see this one, if this for this example, the delta L here is because the S1 R1 distance S1 is 7 lambda. For S2 the distance is 9 lambda. So what's the difference? What's the difference between the length? What's the delta L? You just take 9 lambda minus 7 lambda, you get 2 lambda. Yeah, the difference is 2 lambda. So 2 lambda. So in the end, what do you get, class? This, you see here, it is constructive interference, isn't it? Because they are same direction. Yeah, at this part, this one is going down. The blue one is going down. The green one also going down. So they have the same direction. They have the same direction. So constructive interference, you get, for this example, you get bright fringe over here. Understand? But you see, if like just now 2 lambda, you get constructive interference. But for example, like this one is 9.75 lambda. This one is 7.25 lambda minus, you get 2.5 lambda. You get destructive interference. Okay, maybe this one is, you look carefully. This one, at this part, the point B here is same direction, so constructive interference. But this one, the blue one is going down, the green one is going up. So opposite direction. Like this one, opposite direction. So they have destructive interference. So if you have, like, let's say like half lambda, you get destructive. If you have multiples of lambda, 1 lambda, 2 lambda, 3 lambda, you get constructive interference. Okay, maybe that is what I summarized. If you have 1 lambda, 2 lambda, 3 lambda, you get bright fringe. If you have half lambda, you get dark fringe. Maybe not so obvious. Maybe I show you this way. I show you this way. I show you another way. Okay, so let's say I have okay, maybe wait, let me draw a little bit better. Yeah, nicer. Okay, and one more time. Okay, so let me draw. Okay, draw like this, right? Let me draw. Okay, let's group this. Okay, so now maybe how should I do it? Okay, so let me how should I draw it? So okay, this is the first wave. Okay, first wave. So I draw it. Okay, 1, 2, approximately the same direction lah. Yeah? I want to make it beautiful, nicer. So I draw it 1, 2. Oops, I draw it. Okay, I think there is okay. One more lah. Yeah. It's okay. Never mind. No need so many. So okay, I group this also. Okay, that's good. So class, this is the first wave. Now the second wave. This is the second wave. Yeah. This, let's say the second wave. This is the second wave class. So okay, I want to ask you class. So these are two in phase source. Yeah. Two in you can say there are two in phase sources. In phase means both going up lah. Both initially going up. Okay. So maybe I should okay this one also I group it. Okay. Now, class, there's two in phase source because initially both are going up, Now, okay, wait, okay, so you can see in the end, they are also in phase, isn't it, class? Maybe at this side, you have the screen. You have the screen already, yeah? I make it like this lah, yeah, in the screen. So, two in phase source and in the end, there are constructive interference, isn't it? I want to ask you, is there any difference in their path length in the wave number 1 and wave number 2? Do they have difference in their path length? No difference, isn't it, class? So they have same length, same length. So we can say their delta L is 0 lambda. Okay, got 0 lambda. So what do you get, class? You get constructive interference. So you get bright fringe. Oops. So you get bright fringe. Okay, class? Because in the end, at the screen, they are same direction. So bright fringe lah. Understand, class? So now, now I make it the other case, so you understand, Okay, so now, okay, so now the second case, class. The second case. So, okay, so I put it this way. Now, so this is the first wave. Again, this is the first wave. So this is the first wave. Now the second wave, I move it a little bit. The second wave, I move it here, class. I move it here. So this is the second wave, class. Second wave. So that means now wave 2 travel longer distance. Wave 2 travel longer distance. So how should I draw? This is the screen. This is the screen. So wave 2 travel longer distance. Okay? Wave 2 travel longer distance. How far is long? How far longer? How much longer? This is the wait. We can say this is the extra. This is the path difference lah. This is the delta L. This is what we call the path difference. Understand? Yeah. That means which is this one lah. Yeah. Which is this one, the delta L. I just draw it parallel so that you can see it easier. Yeah, I draw it parallel so that you can see it clearer. Yeah, if this one you hardly see whether it's constructive or destructive. If I draw like this, you can see it better. Yeah, so I simulate this one lah. I simulate this one. Yeah, this part is like the delta L. Understand? It's like the delta L over here. Okay. This is S1. This is S2. Understand? So this part is the delta L, but my delta L now is only how much is the delta L? So this is still consider two in phase sources. Understand? They are still considered two in phase sources. Why in phase sources? Because both going up initially, isn't it? Both going up initially. Okay, both going up initially. So they are in phase lah. Yeah, they start in phase. But how much is the path difference, class? Tell me, class. Tell me. Yeah, it is half lambda, isn't it, class? Half lambda only. Half lambda. So, but in the end, it turned out to be what kind of interference? What kind of interference? This one going down, this one going up. So this is destructive interference. So you get dark fringe over here. Understand? So this one and this one, they opposite direction. So they cancel each other and you get dark fringe on the screen. So what is the path difference when you get dark fringe? Half lambda. Do you see that, class? The delta L now is half lambda. Okay, class, understand? Understand better now? Okay, now good. So now I make it. We give more example. Now we give more example. So okay. Yeah, so now I put it like this way. So now another one. This time I extra distance about 1 lambda, 1 lambda extra. So I make it longer, this one. Make it longer. That means I make it longer here and here. So that means it's going up and then going down. Okay, so this is the screen. Yeah, this is the screen. Yes. So this is wave 1, this is wave 2. This is still considered 2 in phase sources. 2 in phase sources. That means they start with a wave going up. Yeah, wave going up. So which wave travel longer distance? Which wave travel longer distance? S2, isn't it? S2 wave travel longer distance. So where is the path difference? Where is the path difference? This part lah. This part is the path difference, delta L. How much is the delta L, class? Tell me. How much is the delta L? 1 lambda. That's good. 1 lambda. So, okay. So if the path difference is 1 lambda, so what? So on the screen, what happened? Constructive or destructive interference? They become same direction. So they produce bright fringe now. They produce bright fringe now. So do you see, class? Do you see that the path difference is very important? The path difference is very important. The path difference is the one who determines whether you get bright fringe or dark fringe on the screen. The delta L is the one who determines whether you get bright fringe or dark fringe on the screen. The delta L, the path difference is so important. So like this case, the delta L is 1 lambda. That's why I get bright fringe. I get bright fringe. Yeah. So you get bright fringe when the delta L is 1 lambda. Understand, class? Maybe one more last example. One last, but you can predict already, right? Class, you can predict, right? What will happen, right? You will predict what will happen. Okay, so let me just finish this last example before we make a conclusion. All right. Before we make a conclusion, so this delta L is 1 lambda. Now get what? Now is 1.5 lambda. The delta L now is 1.5 lambda. So okay, how should I make it? Okay, maybe just add another one here, right? And then I just ungroup it. Yeah, ungroup it, and I just delete it part by part, slowly. Just do it slowly. There you get it, class. Okay, that's so beautiful, right? So okay, so right. You see that, class? So this is still considered 2 in phase sources. 2 in phase sources. 2 in phase sources because what? Because I start up with oops, what is this? Wave 1. This is wave 2. This considered 2 in phase sources because I start up with the wave going in the same direction, going up, going up. But what happened in the end, class, on the screen? What happened in the end? What happened on the screen, class? The first one going down, but the second one going up. So they are opposite direction in displacement, isn't it? Although initially they are in phase, because they are in phase, but because of the path difference of how much? Because of the delta L of how much? 1.5 lambda. 1.5 lambda. because of the path difference of 1.5 lambda, dia buatkan so in the end, when both wave reaches the screen, the wave 1 is the direction is going down, but the wave 2 is going up. So they're opposite direction. So they, on the screen, they generate dark fringe. On the screen, they generate dark fringe. Destructive interference. The two waves cancel each other. Why like that? It's all because of the path difference. That's why you say here, the path difference decides whether constructive or destructive interference occur when they arrive at a point. Understand, class? Understand? This path difference decides whether constructive or destructive interference occur when they arrive at a point. So, how much is the delta L to produce dark fringe, class? For this case, for the fourth case here, the delta L over here is 1.5 lambda. So I want you to see a pattern here, class. I want you to see a pattern here. From this 4 example, very simple example, you can see a very clear pattern. When the delta L is 0 lambda, 1 lambda, and then what's the next one? What's the next one should be? 2 lambda. I just didn't draw it, but you can predict it. 3 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda, and 6 lambda, and so on, and so on. All this, when the path difference is 0 lambda, 1 lambda, 2 lambda, 3 lambda, and so on, that means I can make a conclusion that when delta L is in the form of m lambda, and the m lambda, where m start from 0, where m start from 0, yeah, the first one is 0, and then 1, 2, 3, and 4, 5, 6. So m must start from 0, and then the next one will be 1, and then 2, and then 3, and then 4, and so on. When delta L equal to m lambda, you produce constructive interference, or you produce bright fringe. Understand? Understand, class? But if you see the pattern here, class, you see the pattern here. If you have, let's say, just one extra half lambda, either is half lambda, 1.5 lambda, you can predict the next one will be, what will be the next one? 2.5 lambda, 3.5 lambda, 4.5 lambda, and so on. So if this case, when delta L is in the form, in the pattern of m plus half lambda, where m start from 0. Remember, m must always start from 0. 1, 0, 1, 2, 3, 4, and so on. Yeah, why I say start from 0? Yeah, so just look at here. Just look again over here. So when m equal to 0, so it's like this one lah. Yeah, if m equal to 0, that means 0 plus half lambda. 0 plus half lambda, you get half lambda, isn't it? You get half lambda. 1 plus half lambda, you get 1/2 lambda. 2 plus half lambda, you get 2/2 lambda. 3 plus half lambda, you get 3/2 lambda. Yeah? 0 plus half lambda is half lambda. So same also, yeah. So m must start from 0 and then 1, 2, 3, 4. So that means delta L equal to m plus half lambda, where m start from 0, 1, 2, 3, 4. So this kind of pattern always produce what? Always produce destructive interference or dark fringe. You see, produce dark fringe. This one produce bright fringe. This one always produce dark fringe. Understand? So this one produce dark fringe. Okay? Do you see that, class? So I can make a conclusion here, which is also actually is showed by this one. That's why with delta L equal to m lambda, you get constructive interference, bright fringe or maxima. Maxima is also called bright fringe. Yeah. If delta L equal to m plus half lambda, you get dark fringe or destructive interference. That's for in phase. But for anti-phase, dia terbalik. Dia terbalik, m plus half lambda become bright fringe. M lambda yang bright fringe menjadi dark fringe. Kenapa macam itu? I will explain also this one. So right now you can first for this one you can make a just a table. At first you just make a table first, yeah, table. So I already can make one for my own lah, yeah. Okay. Another one. Okay. So I always have my own notes. Okay, so two sources. Two sources. Just now I talked about two sources. We are using in phase source. We are using two in phase sources. Okay, so to produce bright fringe or dark fringe. Bright fringe, the delta L must be in the form of m lambda. For dark fringe, the delta L must be in the form of m plus half lambda. Okay, class? Where m is what we call order. We call it order, yeah? Start from 0, 1, 2, 3, and so on. Okay, but now, the next case is anti-phase. Anti-phase. So what is anti-phase, class? Anti-phase, that means this time I terbalikkan. Last time my in phase source means both going up. This one going up, this one going up also. They are in phase. Ataupun you can say like this, yeah. This one also considered in phase. Ini pun in phase lah. Yeah, they start all same direction. Same direction. Kalau anti-phase macam mana? Anti-phase maksudnya dia satu ke atas, satu ini ke bawah. Ini panggil anti-phase. They start up with two anti-phase sources. Ini in phase, going up. This one going down. So all these are in phase. But anti-phase, they start up with one going up, one going down. Anti-phase. Macam inilah. Okay, macam ini anti-phase. Understand? So what happened, class? What happened if anti-phase? Ini boleh terbalikkan ke? Boleh ke saya flip? Boleh flip kejap Bagi saya copy dulu, kelas. Bagi saya kelas. Alright. Okay. So let me show over here. Okay. Just copy and paste. So easy, yeah. Okay. So now let's flip it, yeah. Make it anti-phase. This time is anti-phase source. Two anti-phase source, yeah. Anti-phase that means dia mula dengan satu ke atas, satu ke bawah. So ini kasih dia ke bawah lah. Flip it. Nah, wait. Again. Flip it. Nah, kasih ke bawah. Nah, see that, class? So, ini jadi apa, class? Ini jadi dark fringe sudah, bukan sudah bright fringe. Walaupun delta L-nya 0 lambda. Understand? Dia sudah jadi when anti-phase, start with anti-phase, akhirnya pun anti-phase. So you get dark fringe. So kita tengok yang apa? Ini pula kelas. Ini pula. To in kelas. Ini pula. Ini copy saja ya, copy saja di sini kelas. So apa terjadi kelas? Apa terjadi? What do you think kelas? Now I change this to what? Two anti-phase sources. So I think you can guess kan kelas? You can guess right? Because all of you are very smart. You know, all of you are very smart. Why like that? Why like that? I cannot just select this part. Ungroup it. How to ungroup it? Ungroup it. Yeah. So alright. Can I just select this part? Yeah, I want to. I cannot. What happened, class? I cannot invert it. I cannot flip it, class. What happened? What happened, class? So troublesome, class. Why I cannot flip this thing? Can I? Why? Ya. Itulah silap teknikal tu. So what happened? Yeah, never mind lah. Yeah, I think you can guess right, class. So okay, never mind. Just copy this one and and this one I just delete it because got some technical problem. What is this? Okay, come on. Okay, so this one I flip it, class. So rotate it and flip. See that? Now the path difference is half lambda. Okay, so I add one more. Okay, so this one is now same direction already. So the path difference is still half lambda, but now because it's start with anti-phase going up, this one going up, this one going down. So on the screen, what happened? What fringe do you produce? So instead of dark fringe, now it produce bright fringe. Delta L is half lambda. Do you see the difference, class, between in-phase source and with anti-phase source? Can you see the pattern now? Can you see the pattern? So I can predict. I don't need to copy and paste all the other example, but it's very clear now. So the next one for dark fringe will be 1 lambda, 2 lambda, 3 lambda, yeah, and so on until delta L is equal to m lambda. So produce dark fringe, isn't it, class? For anti-phase source. So for two anti-phase sources. But for this one, bright fringe, the delta L, the next one will be 1.5 lambda, 2.5 lambda, and that means delta L is equal to m plus half lambda. It produce what? It produce bright fringe instead of dark fringe last time. Understand, class? So this for anti-phase source. This for what, class? For anti-phase source. For anti-phase. So anti-phase, kita boleh simpulkan di sini. Kalau anti-phase, bright fringe punya formula, kalau anti-phase, bright fringe punya formula ialah m plus half lambda. That means yang dulu dark fringe punya formula sudah jadi bright fringe punya formula. And then anti-phase punya dark fringe. Anti-phase punya dark fringe ialah M lambda. M lambda. See that? Produce. Okay. Terbalik. Dia terbalik. Dia just terbalik, kelas. M must start from 0, class. M must start from 0. Okay, class, do you understand until now? Do you understand? Ya? Yang lain boleh faham semua? Okay, So, okay. So, let us continue.
Boleh, so boleh.
Right. Yeah, see, my children are singing already. Okay, so alright. Let us continue. Yeah, maybe I give a quiz lah. Yeah, maybe I just give a short quiz. Yeah, I give a short quiz. So let's say the source. Yeah, maybe here. Okay. Make the writing bigger. Okay. So let's say source still so small. Okay, even bigger. Okay. Let's say source 1 has a path of path of 6 lambda. 6 lambda. 6 lambda. And then okay, and then source 2 has path of 9.5 lambda. 9.5 lambda. Okay, and these are two anti-phase sources. Okay, so on the screen, what fringe? Bright fringe or dark fringe, class? What fringe it produce, class? Source 1 has path of something like this. Yeah, what I'm talking about is something like this. So one light wave is shorter distance, another wave is longer distance. So you have to find the delta L, path difference, and that path difference will determine whether on the screen you get bright fringe or dark fringe. Understand? So, and you must check also whether it is these two waves are in phase source or anti-phase source first, before you can know. So got two factor lah. One is you must check the delta L. Another one you must check, is it in phase or anti-phase sources. Then only you can use the correct formula to determine whether it's bright fringe or dark fringe. Understand? Okay, now tell me, class, what is your guess? What is your guess? Bright fringe or dark fringe? What is your guess? Bright fringe? Dark fringe?
Dark, sir.
Huh? Just tell me only, bright fringe or dark fringe? Bright fringe or dark fringe, class? Tell me, class. Bright fringe or dark fringe on the screen?
Dark, sir.
Dark, sir. Oh, okay, dark fringe. Okay, so let us see. So this is S1, this is S2. Yeah. So 6 lambda, that means S1 is shorter lah. That means it's going up this way. S2 she's longer distance. Yeah, longer distance. So 90 degrees. So the first one is 6 lambda. The second one is 9 lambda. That means how big is the delta L? We must first calculate. Delta L is equal to, you must take, not 9 lambda, it's 9.5 lambda, right? 9.5 lambda. 9.5 lambda. So just now you say what? Dark fringe. Okay, good. Let us see. Let us see. So this one is delta L is take the long one minus the short one. Understand? Take the long one, 9.5 lambda minus the 6 lambda. What do you get, class? What do you get? 3.5 lambda lah kan? 3.5 lambda. Good. So this delta L is in the form of what? What formula? M plus half lambda, isn't it, class? M plus half lambda, where M is equal to 3, kan? Betul tak? Nilai M dia equal to 3. Is 3 plus half lambda. Okay, so this one is bright fringe formula or dark fringe formula?
Dark, sir.
Dark. Okay, good. But you must check it is anti-phase source. Anti-phase source. So is this for anti-phase source? Is this formula for anti-phase sources? Dark fringe? Let's check. Again, just now what you learn. Kalau in phase, yes. Kalau M plus half lambda, kalau M plus half lambda, itu kalau in phase. Kalau in phase, delta L ialah M plus half lambda untuk dark fringe. Tapi sekarang you guna anti-phase. You bukan guna in phase, you guna anti-phase. So sepatutnya hasilkan apa? M plus half lambda ini hasilkan apa? Bright fringe, bukan dark fringe. Understand, class? Understand not? Because you are using anti-phase source. So this is anti-phase source. Anti-phase source, you kira dulu dia punya delta L. Dia punya delta L ialah 3.5 lambda. So in the form of M plus half lambda. Yes. So dia memang M plus half lambda. Tapi ini guna anti-phase source. Kalau anti-phase, M plus half lambda itu bukan untuk dark fringe. Dia untuk bright fringe. Kalau anti-phase source, ini jadi bright fringe sudah. Macam ini. Tengok. Tadi, kalau anti-phase, kalau ada plus half lambda tu, kalau ada plus half lambda tu, dia jadi bright fringe sudah. Tengok. The same direction. Dia jadi bright fringe sudah. Bukan dark fringe. Kecuali you guna in phase source. Kalau in phase source, yes. Kalau in phase source, dia jadi dark fringe lah. M plus half lambda tu. Faham tak? So kena hati-hati, kelas. You kena tengok dia sama ada in phase ke anti phase dulu. Sebab soalan ni dia bagi anti-phase source. Anti-phase source. So, M plus half lambda itu bukan untuk dark fringe. Tetapi, untuk anti-phase, dia sudah jadi bright fringe. So, bukan dark fringe. Ialah bright fringe sepatutnya. Bright fringe. So, for anti-phase, this formula is for bright fringe. For anti-phase sources. Understand, class? So right now, do you understand? Everybody? Do you think we can still continue? Do you think we can still continue? I think actually, I think saya kalau nak continue boleh, tapi saya kesian kamu lah, dah jam 10. Ya. So saya masih belum puas ni nak kelas tak cukup lagi ya. Tapi tak apalah ya. So I think until here lah. I think that's actually this is the very main thing ya. This is the very main concept before you enter the chapter. You must understand this first. Yeah, you must understand about what is path difference first. What is the path difference? What is phase difference? Actually, kalau path difference, phase difference, Kalau contoh lah ya, contoh kalau 1 lambda delta L 1 lambda ini dia consider is kalau nak tengok delta phi juga dia consider is 1 lambda is kira 2 pi radian. Ya, 2 lambda is considered 4 pi, isn't it, class? 3 lambda is 6 pi. Ya. So macam kalau 1.5 lambda, okay, this one start with 0 lambda. So 0 lambda means 0 radian. Yeah. So it's kalau kita tengok delta phi lah lagi. Saya tak ajar ya tentang delta phi ni. Saya cuma ajar delta L saja. Ya. So kalau delta phi dia akan jadi 0, 1 lambda jadi 2 pi, 2 lambda jadi 4 pi, 3 lambda jadi 6 pi. Banyak pula nak ajar ni. Ya, kalau delta L half lambda is considered as pi radian. Ya, kalau yang 1.5 lambda considered berapa tu? 3 pi radian. Kalau 2.5 lambda jadi 5 pi. Kalau 3.5 lambda jadi 7 pi. 4.5 lambda jadi 9 pi. So, begini kelas. Kalau nombor genap tu macam ni 0, 2, 4, 6 itu kira ialah for bright fringe. Kalau in phase source lah, kalau in phase source dia akan dapat nombor genap 0, 2 pi, 4 pi, 6 pi. Kalau for dark fringe dia adalah nombor ganjil 1 pi, 1 pi, 3 pi, 5 pi, 7 pi, nombor ganjil semua. Nombor ganjil semua. So that is kalau phase different lah, ya. Delta L is path difference. Delta phi is phase different. Yeah, we have path difference. Where is it? We have path difference. We have phase different. Yeah, kalau path difference, dia tengok 0, 1, 2, 3 je. Tapi kalau phase difference dia jadi nombor genap 0, 2 pi, 4 pi, 6 pi. Tapi kalau dark fringe dia jadi 1 pi, 3 pi, 5 pi, jadi nombor ganjil. Phase different lah. Okay, that's why dalam sini dia ada tunjuk ini. Tengok tak? Sini ada delta L, ada delta phi juga. Ini delta phi saya kurang. Tengok ini delta phi untuk dark fringe atau minima dia adalah 2m plus 1. Nombor ganjil lah tu. Nombor ganjil, nampak tak? Nombor ganjil 0, 1, 3, 5 kan? It's like 2m plus 1. 2 kalau m ialah 0, means is 1 pi lah. Betul tak? Is 1 pi. Kalau m equal to 1, is 2 plus 1. 3 pi lah. 3 pi. Ini nombor ganjil. Ini nombor genap. Kalau m ialah 0, means is 0 radian. Like this one lah. Delta phi 0. Kalau m equal to 1 means is 2 pi. 2 pi. Kalau m equal to 2 is 4 pi. 4 pi. So ini nombor genap. Kalau bright fringe nombor genap. Kalau dark fringe nombor ganjil. Tapi kalau anti-phase punya source dia terbalik lah. Seperti m lambda ini untuk bright fringe sudah jadi dark fringe for anti-phase. So yang nombor apa? Ini salah ni. Ini sepatutnya 2. Ini pun carry forward ni. Ini salah ya. Ini here is 2m pi. Sini salah. Nota salah. Ini patut 2m plus 1. M plus 1 di sini. Salah nota ya. Salah nota. Ini sepatutnya carry forward juga. Ini nota salah ni. So sorry lah ya. So okay, I think that's all lah ya. Ya. You understand lah, genap dan ganjil lah, faham lah? You understand lah? So delta phi itu bolehlah ignore lah ya, kecuali dalam soalan objektif dia bertanya lah ya. Tapi kita biasanya hanya tengok delta L je. Kita tengok yang delta L atas tu. Mostly lah, delta phi kurang kami tengok lah. Okay, just saya jelas-jelas sikit lah. Okay lah, I think that's enough for now, right now, yeah. So not much for today, not much actually, but this is actually the main concept for today. So after this, I can focus on young double slit. Yeah, young double slit, and we will have formula to be used to solve some some tutorial questions. So some tutorial question here. Okay. So thank you, class. Good night.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank
Good night,
you.
sir.
Thank you, sir.
Night. You.
Thank you, sir.
Okay, thank you, sir.
Thank you.